अच्छा बिल्कुल slowly थोड़ा start करते हैं. This one is a new topic, ठीक है? That's electrochemistry. तो उसका basic सा start करते हैं electrochemistry, ठीक है? Let's start revising O levels and जो पुराना AS वगैरह, ठीक है? So first thing, electrochemistry, it's अहमद आवाज आ रही है?
Yes, sir.
As a gain of electrons, that is reduction, right? Okay, that's the first thing. What happens in reduction? The oxidation state decreases. So oxidation state decreases. It's also known as क्या होता है gain of electrons? That's a gain of H atoms. That's not that good of a definition, but it's a gain of H atoms when something gains. So when something gain of H atoms, right? Or loss of oxygen atoms. So that's okay, that's a reduction, right? You get this one. That's reduction. The other one is obviously the opposite, which is loss of electrons. Again, loss of electrons is what? Oxidation. What happens when something gets oxidized? Oxidation state increases. Or vice versa, it's you can also call it as a loss of H atoms. Not ions, atoms. Or it's a gain of oxygen atoms. ठीक है, तो ये clear हो गया कि what's oxidation reduction. ठीक है, you already know this. और इसमें very quickly, ठीक है, let's we're revising electrochemistry now, ठीक है. Now the other thing is कि in a redox reaction, both things happen simultaneously. You have reduction, you have oxidation. ठीक है, let me come up with a number line. Just 1 second. Not this. So on this number line, it's pretty obvious, like people still get this wrong very often. So this is 0, this is +1, this is +2, this is +3, and bottom ke upar this is -1, you've got -2, and you've got -3. Okay, so if you're going in the upward direction, whatever that direction, whatever the numbers are, as long as you're going upward, that's oxidation. And if you're going in the downward direction, that's reduction. So that's a gain of electrons. Now, very quickly, let me अच्छा ये बताओ कि if Cl turns from Cl to Cl -5, what happened? Gain of electrons, loss of electrons?
Gains.
Because that's a gain of 5 electrons to be specific. Okay, so you've got now this one, Na+1 goes to Na+3. अच्छा इसमें क्या हुआ? What happened? Loss of electrons, gain of electrons?
Loss of one.
Okay, that's a loss of 1 electron got produced, right? What happens if let's say oxygen goes from +2 to -2? What happened?
You gain 4.
Okay, so it ended up gaining 4 electrons, right? So just remember that what's going on, okay, whether oxidation is happening, reduction is happening, and it's pretty This thing is pretty obvious, okay? Then you've got redox reactions, okay? Now, first thing, very quickly, okay, when you have a redox reaction, as I remember in electrochemistry, in AS, you did very little, okay? You just did like basic redox, which was kind of just almost the same as what you did in O levels. So anyway, so you got a redox reaction. When you have a redox reaction, one thing is very, very important, and that is, so whenever you have a redox reaction, one atom gains electrons, the other one loses electrons. So if I have sodium and it reacts with Al3 plus and it reduces Al3 plus, and you get what you get. You get sodium plus 1, and you got aluminium. I said quickly identify the element that's getting reduced. कौन सा साथ क्या, which element is getting reduced?
Which element is getting reduced?
अच्छा, Al is getting reduced, right?
Reduced, right? Yes.
And Na goes from Na to Na plus 1, so that's the one that's getting. So that's getting oxidized. So one is getting reduced. The one that gets reduced is known as the oxidizing agent. Okay, that's your oxidizing. And the one that's getting oxidized is the one that's known as the reducing agent. Okay, basics. Then the number of electrons gained and lost, they must be equal. So aluminium is the one that's gaining how many electrons? It's gaining 3 electrons. N is the one that's losing 1 electron. Okay, Na goes from Na to Na plus 1, so it lost 1 electron. Al3 plus goes to Al, that gained 3 electrons. And the number of electrons gained and lost, they have to be equal at all costs. So this has to be multiplied by 3. So there's going to be 3 sodiums. And you just need one aluminium. TK, you don't have to multiply it with anything. So you just need 1 aluminium. So that's it. TK. So that's the basic idea what you did in guess me, you did this in AS, right? And now this is for every equation, you need to have the number of electrons gained and lost. They have to be made equal. Now, before this, you have to also figure out oxidation states. TK, you've done this as well. So I'm going to quickly. I'm going to quickly revise oxidation states. So the idea of oxidation states was that it's what is an oxidation state? It's the apparent or hypothetical charge on the ion, right? So it's the charge on an element in a compound if the compound were ionic. What that basically means is that if you have an ionic compound, first thing, free neutral elements are all. बल्कि पहले वो concept explain कर दूं. So what happens is that if you have an ionic compound, you have one element that is very electronegative. Like in this case, you've got Cl that's very electronegative. It's on the right side. If you know what electronegativity is, electronegativity increases to the right of the periodic table and upwards. So one of these elements, Cl in this case, is very electronegative. So Cl ends up gaining the electrons. So what eventually happens is that Cl becomes -1, Na becomes +1. So this is actually what the charge is, that it is actually an ionic compound. The oxidation state of Na is actually +1 and Cl is actually -1. I said, like, in sometimes what happens is that you have compounds which are not totally ionic. They are close to being ionic, but they're not. The difference in electronegativity is not that large. So, for example, HCl. In HCl, Cl is electronegative, but it's not that electronegative compared to H. Now, what happens in this case is Cl is not able to gain the electrons completely. So the electrons are slightly closer to Cl, slightly further away from H. So H is slightly positive, Cl is slightly negative, but Cl does not really gain electrons. But in redox reactions, we don't really care who's gaining how much electrons. We just care who's the one who's got the electrons, right? So what you do is you treat a covalent compound, a polar covalent compound, but you treat it as if it's ionic, because we don't really care. The question simply is whether the electrons are with H or are they with Cl. If they are even slightly closer to Cl, we're going to say that the Cl is the atom that's gaining electrons and H is the one that's losing electrons. So you're going to treat a polar covalent compound as ionic as well, because we're not really interested in how much Cl is gaining. We just care about the fact that Cl is the one that's gaining electrons, right? TK, clear? Is this clear? Ahmed, clear? Harun, is this clear?
Yes, sir.
So the next thing is that you're going to have compounds that have zero difference in electronegativity. So, for example, if I have an H2 molecule, now in an H2 molecule, no one is electronegative. Like no one is more electronegative than the other one. So the electrons stay wherever they are. Yes, they're going to stay right in the middle. So that means no one gains electrons, no one ends up losing electrons. So the electrons are exactly in the middle. So that's why they're going to have an oxidation state of 0. Now so that's the basic idea of what how you measure oxidation states, figure out oxidation states using electronegativity, and you can apply this to any molecule, any compound. It's going to be applied in exactly the same way. So one example is that if I have a molecule of, let's say, if I have a molecule of oxygen with fluorine, then if you remember, fluorine is the one that's on the extreme right of the periodic table. So fluorine is the one that's the most electronegative element out of all the elements. So the electrons in the bond are definitely going to be closer to fluorine. So as a result, fluorine, the electrons are very slightly closer to fluorine. Like if you're talking about oxidation states, if you're talking about redox, then who's the one that's gaining electrons? It's fluorine. It's fluorine that's gaining electrons, and fluorine would be the one that would be -1, and oxygen would be the one that would be +2. If you have another molecule like H2O2, then the electrons, oxygen is the one that's gaining electrons because oxygen is more electronegative. So oxygen is going to gain electrons from H. This oxygen would gain electrons from H. The electrons that are between the oxygen atoms, no one would be able to gain electrons because they are equally electronegative. So oxygen, as a result, is able to gain electrons from H. So it's going to be -1. It's not able to gain electrons from the other oxygen because they're equally electronegative. This oxygen also gains electrons from H, but is not able to gain electrons from the other oxygen. So oxygen stays -1. H is the one that's losing electrons, so H is +1. This H is also +1. So based on electronegativities, these are going to be your oxidation states. TK, if you just want to further, if you want to, like, if I have a sulfuric acid molecule, so a sulfuric acid molecule looks like this. Now, oxygen is the one that's more electronegative than sulfur. TK, oxygen is the second most electronegative element. So all these electrons are closer to oxygen. These electrons are also closer to oxygen. These electrons are also closer to oxygen. These electrons over here are also closer to oxygen. So as a result, this sulfur over here in the middle, it ends up losing 6 electrons because it's losing electrons to everyone that's around it. So it's going to be +6. Oxygen gains electrons, 2 of them, so that's -2. This oxygen gains a double bond, 2 electrons, that's -2. The oxygen over here also gains electrons from the H as well, so it's going to be -2. This oxygen over here gains electrons from H as well, that's going to be -2. H will be +1, this H will be +1, okay? So that's the basic idea, but that's not, this is just backup, okay? This is just if you get stuck somewhere, finding oxidation states, okay? This is the more difficult way of finding oxidation states, but that's your backup, okay? That's how you tend to technically find oxidation states, but there's an easier way, okay? Like, and you have to remember this way as well, because sometimes the questions can be very confusing, but rarely, okay? Rarely this technique would be used. Like, is this idea clear? The idea clear, electronegativity wala, is this clear?
Yes, sir.
And so now, now the next, and so now the next thing is the easier way, okay, from the table, okay? You probably know all this already. So there's a table, you can just use that for guidance, okay? That is that any free neutral element it has an oxidation state of of 0. Second one is that group, now this is about compounds. So when it comes to compounds, group 1 is +1. Okay, then you have group 3, that's that one is +3. Then you've got transition metals, they've got variable oxidation states. So might be written in the name. So they have variable oxidation states. Then you have oxygen. Is normally it's -2, but there are a bunch of exceptions. Oxygen is -2 because it's one of the most electronegative elements out there. But there's one element that's more electron. So there are very few circumstances. So oxygen is always gaining electrons from other elements. It's always gaining 2 electrons. But there are exceptions. We did 2 of them, except with fluorine or in H2O2. And you've got hydrogen, which is normally it's +1 because it's the least electronegative non-metal. So it's always losing electrons, except when it's with metals. Because it's a non-metal, it's actually more electronegative than metals. So except in metal hydrides, except in metal hydrides, where it's the metal that ends up losing electrons and hydrogen that ends up gaining electrons. And then you have, just a second. So that's about it. So we're just going to practice questions related to balancing equations. Okay, this is going to be the fundamental thing that you do in A2. Okay, these are like basics, but you have to be really good at basics. Okay, you have to be really good at finding oxidation states and about balancing redox equations. Okay, just 1 second. Let me just. तो यहाँ तक क्लियर है ना सर को?
Yes. Yes.
ठीक है, just second. I said just 1 second. Let me just. Also, remember, plus this is AS division. Okay, remember this is like really, really important. Let me just find the worksheet. पता नहीं कहाँ गई है. 1 second रुकना. अच्छा, मैंने समय लैपटॉप आज चेंज किया. फोल्डर्स पता नहीं कहाँ चले गए. अच्छा, just give me 1 second. दूसरे लैपटॉप पे देख लो. नहीं. अच्छा, इसके ऊपर मैं खुद ही I'll just make up things. ठीक है. अच्छा, just very quickly. ठीक है. Remember, it's just basics. ठीक है, तो यहाँ पे वैसे ही कर लेते हैं. अच्छा, so for example, I want to find better. Let's just quickly go over. I'll send you the worksheet. Okay, let's just go over. Okay, if I want to find the oxidation state of I know hydrogen is always +1. Okay, according to the table, hydrogen is always +1. Oxygen is always what? It's always -2. Okay, ये भी ऊपर लिखा है हमने. Okay, remember oxygen and hydrogen are always +1 and -2. Phosphorus is the unknown. Okay, so phosphorus is the unknown, that's X. You just add up the individual charges. The +1 gets multiplied by 3. Then there is +X, -2 gets multiplied by 4. And you've got 0. I'd say solve karo. Okay, what's the value for X? What is the oxidation state of X?
+5.
Okay, so X comes out to be +5. Just similarly, if I have if I have NH4 +1, then the charges, the individual charges, they must add up to the total charge. N is unknown. Okay, that's X. H is what? H is +1. +1 times 4 because there are 4 of them. Okay, the total charges, they must add up to be equal to the total charge, which is +1. So X comes out to be what? X comes out to be -3. Okay, or similarly, you've got, let's say you've got ClO3 -1. I've got, as I come without ClO3 -1. What is the charge on Cl? क्या है इसमें Cl का charge?
+5
+5 ही आ रहा है. ठीक है, +5 है. अच्छा, what about H2SO3? What is the oxidation state of S?
+4
कितना है? +4 है. कंफर्म करो, +4 ही लगी मुझे.
Yes, sir. +4.
ठीक है, so that's +4. What about बस बाकी सारे तो exactly उसी तरह. ठीक है. अच्छा खैर, let's move to balancing redox equations. I told you that in a redox equation, the number of electrons gain and loss, they have to be made equal. अच्छा, मुझे अभी तक वर्कशीट नहीं मिली है. एक सेकंड रुकना. पता नहीं कहाँ चली गई है. हाँ, मिल गया. सॉरी. ठीक है. So now coming to balancing redox equations, right? And remember, your basics, and these are very important, okay? Although you've done this in AS. So let's start with the first equation. Remember, the number of electrons gained and lost, they have to be made equal. So I've got dichromate 6, Cr2O72 minus. It's reacting with HNO2, which is nitrous acid. Achha, and there is some acid involved. Achha, you don't have to really acidic balancing and basic balancing is not really part of your course, so you don't really need to do that. Because if you Google bhi karo, there'll be videos on on acidic and basic balancing, which is not important. Then you've got Cr3+ that's being produced as a product, and the other thing that's being produced is NO3 -1. ठीक है, और इसके साथ क्या है? इसके साथ there is H2O that's getting produced. Now I need to balance this equation. Remember, a redox reaction is not balanced unless and until the electrons gained and lost are balanced. ठीक है? इसमें quickly find out who's the one that's getting reduced. Who's the one that gained electrons? What's the oxidation state of Cr over here?
+6.
Okay, so Cr over here is, I mean, we know oxygen and H is +1, O is -2, +1. So we don't really care about them. अच्छा, लेकिन Cr over here is +6, ठीक है? ये तो सारे agree करते हैं ना, that's +6, right? And Cr, you confirm कर लो, it's +6 or not. अच्छा, then you've got Cr on the other side is +3. So what happened to Cr? It ended up doing what? It ended up gaining. It ended up getting reduced. So it gained how many electrons? It gained a total of 3 electrons, right? So now, so we figured out who ended up gaining electrons. Now also figure out what happened to nitrogen. What's the oxidation state of nitrogen over here?
+5
Okay, so nitrogen is, is it +5? Are you sure?
So it might be +3.
+1 or nitrogen is unknown, that's X, and -2 times 2, and that's the whole thing is neutral, so that's equal to 0. So it's going to come out to be +3. So what about N over here? यहाँ पे क्या है? प्लस कितना है?
So for the CR207, isn't it 7 plus 7?
I mean, you can check it. CR is the unknown, right? So it's X. You got 2 CRs, that's 2X, and then there are 7 oxygens, so that's minus 2 times what? 7. And the whole thing is now equal to, what is the total charge? It's minus 2, right? Asina, is this clear that that's what you came up with, right?
Okay, so got it, sir. I forgot to do the -2.
ठीक है. So that's why it's going to come out to be plus 6. So okay, NO3 minus 1. What is NO3 minus 1?
Plus 5. Sir.
ठीक है, that's plus 5. So it lost how many? It lost 2 electrons, right? So the number of electrons gain and loss, they have to be made equal, right? So one of them is gaining what, 3 electrons. The other one is losing 2 electrons. So I would have to multiply both of them with a number. I'll multiply the first one by 2 and I'll multiply the second one by 3. So that means I need to have 2 CRs because CR was gaining 3 electrons, right? So I need to have 2 CRs. I already have 2 CRs. So I can have 2 CRs on the other side as well. And I need to have 3 nitrogens. So there's 1. So I'll just multiply it by 3. And I'll multiply the other one by 3 as well. There's 1 nitrogen, right? So that makes the number of electrons gained and lost equal. Now the last part, which is going to be relatively easy, and that's now you've got to balance the only thing that's left is this thing and water, the one that were not involved in the redox part. So how many oxygens do we have? I've got 7, I've got 6 over here. So that's a total of 13 oxygens, 13 oxygens on this side. So I need 13 oxygens on this side. So that's 3, that's 9. So I need 4 oxygens on this side. So there should be 4 water molecules, and then we can accordingly balance the hydrogen atoms as well. That's 8 H's on this side. So there are 3 already there. So I guess there's just going to be 5. Okay, is this clear?
Yes. Sir.
Asina, clear it? Is this clear?
Yes, sir.
Achha, so we'll just keep doing this because this is something that's going to be very basic in A2 chemistry when we start A2 electrochemistry. Let me just tell you what A2 electrochemistry is. In up till AS, what you had was that you had these equations already made for you. You just had to like balance them. That's it. A2 electrochemistry is all about making these equations, right? It's about making these equations from scratch. Like if I tell you this is what A2 electrochemistry is going to be about. If I tell you that there's Pb2 plus ions and they're being added to a solution of Sn2 plus ions. So A2 electrochemistry is they're going to ask you what's going to happen. Who's the one who's going to lose electrons? Who's the one who's going to gain electrons? So right now we have no idea. Like I don't know what Pb2 plus wants to do. I don't know what Sn2 plus wants to do. I've never actually seen the reaction ever. I've never even read about the reaction. So A2 electrochemistry is all about finding out that they'll give you an element, and you would have to make an idea about what kind of reaction is going to happen. I mean, it's going to be a redox reaction, but who's the one that's going to lose electrons? Who's the one that's going to gain electrons? And do they really like to lose electrons or not? So there's going to be some part which would be about feasibility as well. So that's the basic idea. Like all these equations in A2, you'll be making all these equations up from scratch. So next equation, TK, I've got this equation, which is IO3 minus 1 reacting with N2O. Plus H plus 1. अच्छा, फिर उसके बाद है कि it's I2 and there is NO. And I think there's H2O at the end. There's going to be H2O. Now you've got this redox reaction happening. We need to balance this redox reaction. First thing, what's the oxidation state of iodine over here? Yeah, man. I mean, oxygen, I know it's -2H +1. What's iodine? Okay.
+5.
So iodine is going to be +5. What's iodine over here? It's a neutral element, right? So that's that one is 0, right? So that's 0. So that means iodine is the one that ends up gaining gaining 5 electrons. Okay, is this clear? Achha, N ka, what is the oxidation state of N? Like over here.
+1.
So N is +1. What's N on the other side? That's
+2.
+2, right? Achha, so N is the one that does what? That gains, it loses 1 electron, right? So it loses 1 electron. So I've got the number of electrons gained and I've got the number of electrons lost. All I need to do is I need to just make them equal. So I'll multiply the first one by 1. I'll multiply this by 5, right? So I'll assess that way. The equation will be balanced, right? So I need 5 ends. Now I need 5 ends. There's one issue that I can't really make this 5. I would have to go into fractions, right? Because I need 5 nitrogens, right? So I would have to multiply this by 2.5. So instead, what I'll do is I'll change the number. I'll just double it. So I don't need to go into fractions. I'll just multiply this one with 2 and this one with 10. So I need 2 iodines. So there's 2 iodines already on the other side. And I need 10 nitrogen. So I just need to multiply this with 5 and I need to multiply this by 10. So now the number of electrons gained and lost are equal. Ye clear? Is this clear to everyone?
Yes.
Yes, sir.
So finally, what you have to do is you just have to take care of H and O, right? So how many O's do we have? That's 6 plus 5, that's 11. So that's already 11. So I just need, so there are 2 H's. So there should be just 2 H. That's it. 2 H's. That's it. That's balanced. Okay. So just try and go through this. Okay, try and do this quickly. Either okay, if you can just figure this out on your own. IO4 -1. Plus there is, I think pH 3. And so sorry, 1 second. So, and the product is I -1 plus P4 plus H2O. अच्छा ये बस last कर लेते हैं. So what's I initially? Okay, what's I over here?
+7.
+7.
Yeah, that's +7. And P I think is what? It's -3. I is obviously -1 and P is 0 over here. That's it. So let me just double check. Is this equation? I've done it correctly, right? अच्छा, I goes from +7 to, ठीक है, that's fine. So how many electrons, what happened to I?
Gain of 8.
Gained 8 electrons.
ठीक है, so it ends up gaining 8 electrons. P on the other hand goes to 0, so that means it lost, how many lost 3 electrons, right? So you just have to make them equal. So I would have to multiply this by 8 and multiply this by 3. So I should have 3 iodines and I should have 8 phosphoruses. So if दूसरी side पे I don't have to multiply it by 8. 2 would do the job. 8 phosphoruses. And I guess that's it. So H, only thing is H. I've got how many H's? 24 H's on the left side. So I'll just multiply it by 12. The oxygen would probably be balanced. There's 12 on the other side. Yes. ठीक है. So clear, I'll just be sending this worksheet. ठीक है. Try and go through this. Remember, this is it. ठीक है. This is all you did in AS. I think you didn't do anything else apart from this. Just finding out oxidation states, and you did disproportionation reactions. We're going to do that as well. वो कल कर लेंगे, but we're going to start with A2 electrochemistry from tomorrow. ठीक है? Remember, this is going to come up again and again. I mean, this basic stuff. We'll also talk about half equations. That is going to, I mean, what you can also do is, but we'll talk about in the next class. ठीक है? I mean, the same thing can be done using half equations, which is kind of the same thing. ठीक है? लेकिन let's do that tomorrow. तो ठीक है, कल फिर कंटिन्यू करते हैं 10 से. ठीक है, कोई क्वेश्चन नहीं है किसी का?
No questions. Thank you.
चलो, ओके, टेक केयर.
Good office.
हाफिज.
Good night.